Today's lesson, section 4.4b, we'll be talking about our laws of logarithms still. Just to review, the laws of logarithms are the product, quotient, and power, and I have them rewritten here. So, in example 2, we would like to be able to use the laws of logarithms to be able to expand our expressions, so to create as many logs as possible using our properties. So, for like letter A, you have the log of x cubed y to the 6 base 5. And so here I see that there is multiplication between my x cubed and y to the 6. So then I would like to use the product property to separate them. So product property tells me that when I have two multiplied to each other, I can write them separate with addition in between. Notice how I still use the same base, and I don't change anything else. I just create two logs instead of a single log. Okay. Now I also see that there are exponents for each of them, so I can use the power property and move them to the front. So then I get 3 log of x base 5 plus 6 log of y base 5. And then here, noticing that there's nothing else that is multiplied, divided, or to powers, I know that I'm done. I have expanded as far as I can go. So moving on to letter B, now the same properties work for ones with ln's. It's just a different base, basically. So here I see that I have multiplication, I have division, and I have a power, because it's a cube root. Remember that cube roots are the same thing as rational exponents, so it would be the 1/3 power, basically. So here, I want to first take away the division. So I'll write ln of the top, so a times b, and then minus ln of the bottom, which is the cube root of c. Okay? And then also, I want to notice the two things that are going on. So I have multiplication here, and I have a power here. So I want to rewrite my power, and I want to separate my multiplication. So here, multiplication, using the power or product property, I would have ln of a plus ln of b, and then still minus ln of c to the 1/3 power. Remember, that's a radical, and I can change it to a rational exponent. So the root is the bottom, and then the number of c's I have is the numerator. So 1/3 is what I get. And so now I have a power, so I want to move that in front. So ln of a plus ln of b, those ones are already taken care of, so I don't have anything else to do. And then minus 1/3 this time times ln of c. Okay? And so since there's nothing else to power or multiplied other than a scalar in front of the ln, I know that I am complete. So I've expanded this expression as far as I can go. Now I want to be able to do it the other way. So example 3 says use the laws of logarithms to combine each expression. So I want to be able to put them all into one log. Okay, so I'm not going to have log over log or anything like that. I'm going to have a single log representing the entire expression. So you kind of do it in the backwards order. So if you notice from the top, I kind of did quotient property first, if there was one, and then I did product property, and then I did power. So I kind of like to do it in the same order, but here there's a little tweak to it, because sometimes quotient property is tricky. So to negate that, I'm going to do something else, but we'll take what we're given. So usually power properties first. Okay, so here I have a 3 out front and a 1/2 out front. So using the power property, I'm going to reverse this, and I'm going to put these back up as exponents. Okay, so then I get log of x to the 3rd power plus I get log of x plus 1 to the 1/2 power. Okay. Now here, I see that there's only addition in between these two logs, so then that means it's the product property. So then this and this are going to be multiplied to each other with a single log in front of it. So log will be x cubed times x plus 1 to the 1/2 power. Now here there's no other properties. You can change the radical or the 1/2 to a radical or square root if you want, but there's no need really. It's the same thing. Okay, so here I am done because there's no subtraction, there's no addition, and there's no numbers out front of a logarithm, so I know I'm done combining this expression. Now letter B, same thing. Now this is the tricky part. So you could ignore the negative sign here and just wait till the end. But sometimes that kind of makes the logs for the quotient property tricky. So how I'm going to tell you to do this will negate that problem. You won't have to worry about it. Okay? So I want to use the power property here. So the 3 is going to go up to this s. The 1/2 is going to go up to the power of t. And I'm going to take the negative with me with the 4 and put it up to the power for the t squared plus 1. Okay? So anytime you see a negative, it probably will make it way easier in the end if you just move it with your scalar, even if it's just minus ln. Just treat it like it's a -1 and move it to the top. This will make it a lot easier because the quotient property kind of, like if you do it in the wrong order for particular ones, then you won't get the proper division that you want. And so you might be dividing by something you don't want it to completely divide by or correctly divide by. So here, if you move it all up with the negative, then it kind of takes care of itself later in a later step. Okay? So let's tack it on with the 4 to move it up. So then that gives me ln of s cubed plus ln of t to the 1/2 and plus ln t squared plus 1 to the -4th power. Okay, so now I have all plus signs in front, or in between my ln's. So now all I need to use is the product property to put them all together. So I'm going to multiply s cubed, t to the 1/2, and t squared plus 1 to the -4th power. So I get one single ln, so s cubed t to the 1/2 times t squared plus 1 to the -4th power. Okay, so now I can simplify this a little bit because of the negative. That tells me it should move down, so it makes it a fraction. So then I can write ln of s cubed t to the 1/2 over t squared plus 1 to the 4th power. Okay, and so then you get the division properly where it's supposed to go, and then you never have to think about where it should or should not if you need to check your stuff. Okay, so makes it a lot easier. Alright, next part is change of base formula. Now sometimes you're given a logarithm with a interesting base that you can't use to plug into your calculator, so you can't really find the value of it. So using the change of base formula, you can change the base to a base that you like to see. So it says that the x will be on the top, so log of x to your new base a, and then the b will go down, so the old base will go on the bottom with your new base. So usually a, so you can plug this into your calculator. Okay, a, you want it to either be 10, so a common log, or e, so natural. It doesn't matter which one you use. You can use either one, it doesn't matter. But you want to use one of those two so that you can actually plug it into your calculator to get the correct number. Now I know some calculators already do this, where it has a change of base formula where you can type in the base, but some calculators don't. So It's nice to have this in your repertoire for tools, so that if you forget how to do it on your calculator, you have this as well. Okay, so I want to be able to evaluate the following expressions. So for log of 5 base 8, here I want to take log of 5, and let's say my base is 10. So I'm going to say a is 10, and then log of 8 is going to be base 10 as well. So now I can use common log in my calculator and type that in, and it gets me 0.774. It doesn't say it around, so I can leave it like that if I'd like. Okay, same thing with a log of 20 base 9. Here I could change it to ln, so natural log, so then ln of 20 divided by ln of 9. Okay, and so then when I actually divide that out, that gets me 1.363. Okay, now if you're rounding, that would be rounding to 1.8. This one would be 1.4, but it doesn't say it went around, where to round to, so I can do what I'd like. Okay? Have fun.